Hello, I'm Elian Saint-Hilaire, and in this third mini lesson on the mesh networking, we are going to talk about the communication between two nodes. So let's suppose I have two nodes, and they wanted to communicate between each other. We have to start out by pointing out that the first way that a new node that just shows up on the network finds other nodes is through a broadcast mechanism. So we basically do a small packet broadcast, a little bit like universal plug-and-play UPnP. It's a little bit like that. We just do a little broadcast, and we can find nodes on the network. Now we only need to find one node. We don't need to find all of them. We don't depend on the broadcast or multicast system to find the nodes around us. We only depend on the multicast system to find one. Once we found one node, all the other nodes on the network that this node already found, well, we'll be able to use that to start walking the mesh. So the first bootstrap, if you will need that multicast. Now, once we've done a multicast on the network, some nodes, and I won't go into the details, there's a special algorithm for this, but some nodes will answer, and basically what they'll do is they'll do a TCP connection with TLS, so it's a TLS secure connection, from the node that receives the multicast back to the node that wants to find wants to find partners on the network. So this TLS connection will be mutually authenticated. That's because mutually authenticated means that we're going to use two certificates. We're going to use a certificate of the client. In this case, the one on the left here is the client. This one on the right is the server. But it doesn't really matter. We're going to use the certificate, the self-signed certificate of both nodes in the TLS connection. Now, some people are going to be picky and are going to say, wait a minute, you can't do that. Yes, indeed, what we do is we create a derived TLS client certificate and server certificate. We derive from the respective self-signed certs. We derive a TLS certificate, and then that derived certificate is the one that we use for the TLS exchange. But both client and server in this case will be sending their respective TLS certificate and their root certificate, their node certificate, inside the exchange. So at that point, both parties, after the TLS negotiation is completed, both parties will be able to compute the node identifier of the person they're talking to, the node they're talking to. So what you do is you verify the certificate chain, make sure it's all right, and then you take the hash of the public key of the certificate, one above the TLS certificate, so the node certificate, and then you compute the hash. It's a SHA-256, and you get the node ID of who you're talking to. Now this is very useful because now you can, in your table, you can say this node ID is at this IP address, and the other person can, or the other node can do the same. This node ID is at this IP address. And they can start filling their tables. Okay, so this is very useful because then this node can start reporting to his buddies, hey, I found this new guy on the network. This is his node ID, and this is the IP address I found him at. So these other nodes can start connecting to him, and he can also learn about nodes from his table and start connecting to those. So it's a very interesting trade. So now I will point out once again that in this mechanism, there's no way for a node to impersonate another existing node. The worst you can do is keep showing up as a different node every time you connect on a network. You could create a new certificate and show up as a new identity every time. But you wouldn't be able to impersonate an existing node on the network as yourself. You wouldn't be able to do that. Okay? So now we have this TLS connection, and one of the rules we apply inside the code is that we will not change this table. We will not change our internal state database unless we can prove that the row that we're changing with the node ID here, that we've proven that the information is correct. So in this case, we have a TLS connection, we have mutual authentication, so both sides can prove the other side's node ID and they can start filling their information. It doesn't mean you're not talking to somebody that's a bad guy, but at least you know what node ID they are. Okay? Now, for efficiency's sake, the connection, the synchronization between two nodes occurs quite often. So, you know, usually it's between 10 seconds and a few minutes. Each node will synchronize with another node. Now, what we could do is do a TCP, TLS, and a full mutually authenticated connection every time. Or we could use the session resume in TLS, and that will be a little faster, but it's not really convenient. What we want to do is we want to switch from using this TLS to a UDP protocol as soon as possible. It's much lighter weight. Statistically, it still works. We don't need it to work all the time. We just need it to work sometime. So what we're going to do is we're going to create this key system. We're going to exchange a key during the TLS negotiation. So we're going to exchange a key. So in this case, we'll call it C. He's going to have a key for C. He's going to have a key for S. And then what we can do is drop this TLS connection. And from now on, we can use just these keys to send encrypted packets, encrypted UDP packets between the two nodes. So this is much more efficient to do it this way. Most of the time, we will not have to go back to TCP ever again. The cases where we do go back to TCP is if a node sends UDP packets to another node and does not get a response after a certain time, then what we do is we fall back to TCP. So for example, let's suppose I do a TCP connection and with TLS, mutually authenticated, trade the key, and for some reason the node on the right decides to reboot. When they reboot, he loses its key, the key for the other guy. So he loses that. And so now, whenever somebody sends a packet to him, he cannot decrypt it anymore. So it falls on the floor, he can't decrypt those packets. What the node that doesn't get any answers will do is after a while, he'll switch back and perform a TLS connection, again with mutual authentication, and then re-exchange the keys. So there's a fallback timeout. Usually it's a minute or two, depending on how fast you synchronize. So usually you want to allow for a few UDP synchronization to occur, and then if they all fail, then you fall back to mutually authenticated TLS. If the TLS then fails, you can conclude that this node has now disappeared from the network. But usually that's a process. You try a couple times with UDP. If it fails, you switch to TLS. If that fails, you remove that node from your table. But if it does succeed, then you reestablish your keys, and then you're back to doing UDP again. So that's roughly how we synchronize.